So I'm gonna read all of this and then I'll show you how to do it. I'll show you how to do it, man. A cyclist starts pedaling and accelerates for 12 seconds. The table below gives the velocity v of the cyclist in feet per second at time t in seconds. Okay, so this is the time and this is the velocity. So at 2 seconds, they're going 6 feet per second, it says. Okay, at 10 seconds, they're going 9.5 feet per second. So that's what that means. The area under the velocity, remember, velocity is a rate, right? So the area under the velocity function just gives you the distance that is traveling. Gives you the distance that the cyclist travels, right? Because if the velocity is feet per second, the area underneath is just the feet. Defeat. He's defeated. That's what you call a guy with no feet. Never mind. Distance the cyclist travels in 12 seconds. Okay, yes, that makes sense. Let's use R6, the right Riemann sum, with 6 equal subdivisions to approximate this area. Well, I don't even know what R6 means if I don't got a picture, so I'm going to make a picture out of this table. Alright? I'll make a picture. I'll draw the X and Y axes. On the X axis, there's going to be time, so it'll count all the way up to 12. I think it counts by 2s, right? 2, 4, 6, 8, 10, 12. Okay, so I do the same thing. So that's easy. And then this one does not count by anything in particular, but I'm gonna go all the way up until 10. So I'll just count by 1s on that. I label it every other number just so I can keep the spacing nice. But there we go. I'm ready to plot this stuff. I'm plotting this function. I mean, I don't have a formula for it, but I can definitely plot this and connect the dots. So 0, 0. So that's his velocity at time 0, and then he's accelerating, so he's going to get faster and faster. At t equals 2, we have 6. 2, 4, that's real quick. That's real quick, man. At 4, it's 7.5. 4 and 7.5, and something like that. At 6, and then you just plot these. I'm plotting the points like a garden. What? So there's my plot, and I'm just going to connect these with a line, a curve. So that's what kind of the graph looks like, and it says 6 subdivisions. So I have to divide from, I guess I should erase this part, right, because it only goes up to 12. That's not really lined up, but it's supposed to be. Whatever, close enough. So 6 subdivisions. Well, I count up all the way to 12, and I have to make this into 6 equal subdivisions. That's pretty easy. Just take 12 divided by 6, and that's the length of each subdivision, right? Or the base. So what's 12 divided by 6? 2. So that means each base of my rectangle is 2, right? 2, 2, 2, 2, 2, like ballet. No, not at all. And then the right sides of these intervals, the right sides, the top right corner, has to touch my graph. Okay, that's what R6 means. We know that. So the right side here has to touch, so I go over, and then I stop, and then the right side here has to touch, and I go over. Wait a minute, what about, I just bring it down. Okay, and then the right side there. Right, I'm just doing this. The top right corners have to touch. So the top right corners touch. Hopefully that's straightforward. And then here's the top right corner. Move over. See, top right corner of this rectangle is touching. The top right corner of this rectangle is touching. I drew this part bad. I'm going to redo it, but so there we go. I drew it. You should think in your head, is this an overestimate or an underestimate? I hope you can see it, but I'm going to say right now, hopefully you thought of it, this is an overestimate because we have too much area over here, right? This is an overestimate. It's not always the case that the right Riemann sum is always an overestimate. We saw that in that first video. But for this particular graph, it is an overestimate because we're counting too much area. If you are confused at all about how to draw this, let me know, and I can make up some examples and show you. All right. So the area, what is the value of R6? Well, R6 just means the area that's approximated with 6 rectangles. Let's count. Let's make sure we have 6. 1, 2, 3, 4, 5, 6. Good. And what do we have? What is it? What is it? Well, what's the area of this rectangle? I mean, it's just like that first problem. The area of this would be base is 2 times the height. The height was 6. Even if we didn't know if this didn't line up perfectly, well, we can plug in 2 to our function. We don't have a function, but we do have a table. So that's 2 times 6. So what is that area? That's 2 times 6, that's 12, plus this area. Well, what is that? That's 2 times this height. What is that height? Well, when you plug in 4, what do you get? 7.5. So it's 2 times 7.5, 14, 15, right? And then the area of this one, and so forth. You just get the areas of each. You can get the heights by plugging in the right side of that rectangle. Sweet! Hopefully that's not too confusing. So maybe, well, I forgot to tell you to pause it, but like those are all the areas. Maybe you should try and get those. And then I add them all up to get the total approximate area, which will be an overestimate. And that gives me, I hope I'm right, but that gives me 101. And remember, because this was in feet per second, right? This was feet per second. Feet. When you get the area underneath, it's just feet. So that's cool. And the distance traveled is, if you clicked on this drop-down menu, it would say an overestimate or an underestimate or whatever. So we would say the distance traveled, the actual distance. So this is no longer, they're not talking about the approximation. They're saying the actual distance traveled in 12 seconds is less than 101. It's less than R6 because R6 is an overestimate. So that's what it would say on the drop-down menu. So there you go. That's how you do that example. It's important that you know how to draw this because that's how you discover what they're asking for. Sometimes they would say the right-hand rule, the right Riemann sum, that means the top right corners touch. The left Riemann sum means the top left corners touch. So maybe if I did that in green, the first value would have an area of 0. The second one would be like this, right? The green would be the left Riemann sums. This would be an under approximation, right? I'm not going to keep going, but there you have that. And then midpoint, remember, you have to make your intervals and then go up to the middle and then make your rectangles. So careful with those. And that's all. That's all.